So this is Lab 5, Rocket Launch by Nicholas Schweiker. So for the introduction, I analyzed the flight path of SpaceX Starship on its first test flight. Someone took a stationary video on a nearby beach, so I analyzed that. The purpose of the lab is to analyze the first section of the Starship launch and compare it to a computational model in GlowScript. The video will be analyzed using Tracker and compared to the GlowScript code's data. And a brief preview of the lab is that the Y data, like the altitude, is similar, but the X data had significant error because the camera was shaking. So for the main physics ideas, first we have Newton's second law, force equals mass times acceleration. The thrust of the rocket produces acceleration upwards. And then we have velocity update formula, where the velocity is equal to the initial velocity plus acceleration times time. We use that in the GlowScript code, same with position update formula, but instead of acceleration in there, we sub it for net force divided by mass. So for the observational model, the rocket was launched from an altitude of 0 meters. We used Tracker to analyze the movement, and then we set up a coordinate system with the origin from where it was launched. Y direction is straight up, X direction is positive to the right. We were assuming that the rocket is not moving in the Z direction because it cannot be measured in Tracker. We used the calibration stick through analyzing another launch video, which showed altitude to be at 15 seconds. So using that, we were able to set the calibration stick. So for the observational data, the X is generally decreasing as it's going through its roll movement, but the camera's kind of shaky, so that's why there are those spikes, especially at the end. For the Y position, you can see it increasing. It doesn't increase as fast because the air resistance is rising over time. So here's the theoretical model, initial conditions. The rocket's mass is 5 million kilograms, which is the Starship wet fuel weight. And then initial position and velocity are 0, and then gravity is also set to 9.8 meters per second squared. And then for the rest of the GlowScript code, we use the force of the gravity, which is just the rocket mass times gravity. And then force of thrust was found online for Starship, and then we multiplied that by the unit vector. We assume that it's 99% going up, 1% to the left. And then we add both gravity and thrust force to find net force, and then we use velocity and position update to update the positions, and then we create the visual and create the graphs. Here is the Y direction on the top, the position and velocity graph, and on the bottom is the X direction, position and velocity graph. Pretty straightforward. So as for data comparison for the Y position, you can see that the theoretical is increasing more at a increasing rate, while the observed is more linear. That is likely because of air resistance rising. Comparing the X position data, you can see that it is roughly similar for the first like 2/3 of the data, but the camera being shaky does throw it off and causing those spikes. But if it wasn't for that, the data would likely look very similar. So for potential errors, the video is very low quality and it's hard to track in Tracker because it's very faint and hard to see, and I could only download it in 720p. The camera is not perfectly stable, which has a big effect on the X direction. And then also we assume that the rocket is not moving in the Z direction, and that is flawed and causes the perspective of the video to be off. Then additionally, we do not take into account air resistance, which is growing, especially as the rocket is starting to move quicker. So to conclude, the Y position and velocity data between both the models were very similar. The X position and velocity data between the models were similar, but it had significant error due to the camera instability and shaking. Errors could be potentially removed by finding better footage of the launch that is less shaky, or using actual flight data during the launch. The Y position and velocity data were slightly different because the rocket does not have constant thrust. It is throttled at different points. Aerodynamic drag is increasing for the first part of the flight, and the rocket gets lighter as it burns fuel in its oxidizer. So one way we could combat this is finding a better video, of course, and then also modeling it different in GlowScript to have variable mass and thrust.